Hi everybody, Bob Rasooli, Orange County, California. In this video, we're going to solve an API 570 exam-style problem entirely by calculation. I'll read the scenario once, then walk through the logic, the equations, and the numbers out loud so you can follow along and copy the math on screen as I speak. We're in the FCC-unit gas concentration section. We're looking at a propane-rich light ends transfer line coming off the wet gas compressor and heading through the gas plant to recovery. It runs hot and under enough pressure that if it leaks, it will rapidly vaporize. The line routes above pipe racks within the unit and passes near occupied areas during day shift. The circuit is carbon steel, insulated, nominal NPS 6, and we have established CMLs. At the same CML, our inspection history shows two ultrasonic thickness readings. In 2020, the thickness was 0.350 inches, and in 2025, the thickness is 0.300 inches. The inspection record that we updated in 2025 also lists the remaining corrosion allowance. This is the current metal margin above the minimum required thickness as 0.080 inches. There has been no RBI reassessment. We are planning by code-based intervals. No changes in metallurgy service or operating envelope have been recorded since 2020, and nothing suggests localized thinning at this CML. Before we touch the math, classify the service. This is a propane-rich light hydrocarbon that would rapidly vaporize on release, and it's within the unit. That is Class 1 service. Class 1 matters because Table 1 in API 570 caps the thickness measurement interval at 5 years. And the code rule says we must use the lesser of half the remaining life, or that table maximum when RBI is not being used. Now let's calculate the corrosion rate using the point-to-point short-term formula. Say it with me. Corrosion rate equals prior thickness minus current thickness divided by the time between readings. That is, CR equals T previous minus T current over delta T. Plug in the numbers. CR equals 0.350 minus 0.300 divided by 5 years. The numerator is 0.050 inches. Divide by 5 years, and we get 0.010 inches per year. So the corrosion rate is 0.010 of an inch per year. Next, let's convert the remaining corrosion allowance into remaining life. API 570 defines remaining life as actual thickness minus required thickness divided by corrosion rate. But our inspection record already provides that numerator directly as the remaining corrosion allowance. So we can use the clean form. Remaining life equals RCA divided by CR. That's RL equals 0.080 inches divided by 0.010 inches per year, which gives 8 years of remaining life based on the 2025 condition. With remaining life in hand, set the thickness measurement interval per code. The rule is the minimum of half the remaining life or the Table 1 maximum for the class. Half of 8 years is 4 years. The Class 1 table limit is 5 years. We must pick the lesser, which is 4 years. Therefore, the next required thickness measurement interval for this circuit is 4 years. Because our last reading was in 2025, the next UT thickness check is due in 2029. I'll recap the chain in one breath so it sticks. We recognized a rapidly vaporizing propane-rich stream in an FCC gas plant line, so we treated it as Class 1. We computed corrosion rate as 0.350 minus 0.300 over 5 years, giving 0.010 inches per year. We took the remaining corrosion allowance from the inspection record, 0.080 inches, and divided by the corrosion rate to get a remaining life of 8 years. Then we applied the code rule for non-RBI intervals, used the lesser of half life or the table maximum, and chose 4 years over 5. Final answer. The next thickness measurement interval is 4 years, due in 2029. 2 quick teaching notes as you practice these. First, don't rederive minimum required thickness when the remaining corrosion allowance is already documented in the file. Use RCA directly in remaining life equals RCA over CR. Second, always classify the service first, because that drives the table cap and can change your final interval even if your remaining life is large. That's the complete solution. Clean, code-aligned, and exactly the level of calculation the exam expects.